Express the quadratic function f of x is equal to negative 3, x plus 2 squared minus 6 in standard form, then graph the function. The function that we're given is in vertex form. And the first thing I'm going to do is I'm going to rewrite x plus 2 squared as x plus 2 times x plus 2 because it will help us with the conversion. Now, if I didn't have that minus 6 here, you would see that it appears as if it's the factored form, and we already learned how to convert the factored form to standard form. So the steps are the same, except that we will need to add this number at the end. The order in which you multiply these three factors together does not matter. I'm going to multiply the last two factors together first. I'm going to start by distributing the x through. So x times x gives me x squared, and x times 2 gives me positive 2x. Then I'm going to distribute the 2 through. 2 times x gives me 2x, and 2 times 2 gives me positive 4. Next, I'm going to combine my two middle terms inside the brackets here to simplify, and I know that 2x and 2x when combined gives me 4x. Then I'm going to multiply the negative 3 by each of the terms inside the brackets to give me negative 3x squared minus 12x minus 12, and then I have that minus 6 at the end. And the last step to get it to standard form is to combine these two numbers, because as you recall, the standard form has the form ax squared plus bx plus c. So I should only have three terms. So combining negative 12 and negative 6 gives me negative 18. So this right here is the standard form. Okay, this is the vertex form I started with. This is the standard form. Now the second part of the question asks us to graph the function. Now we can use information from both of these functions to create the graph. From the vertex form, I can tell you what the vertex is. The x-coordinate of the vertex would be the number that I'm subtracting from x. In this case, it's negative 2. And I would be subtracting negative 2 in order for me to see plus 2. And the y-coordinate of the vertex is the number that I'm adding at the end here, and it happens to be that I'm adding negative 6 here at the end. So that's my vertex. Now from the standard form, I can tell you what the y-intercept is. It's this number at the end here, because when x is 0, these two terms will go to 0, and I'll be left with the y-intercept of negative 18. So the y-intercept has the coordinates 0, negative 18. Now that I have those 2 points, I can plot them and then use symmetry to find the third point. So I don't really have to do any calculations during the graphing steps. I just use the information from both of my quadratic relation forms. I'm going to scale the x-axis by 1s, and I'm going to scale the y-axis by 3s. You can also scale by 6s if you wanted to. Okay, so now I can graph. By plotting the 2 points, I have negative 2 and negative 6. And my y-intercept is here at 0, negative 18. And I know the axis of symmetry passes through my vertex. So the third point would have to be located here, 2 units away from the axis of symmetry, just like the y-intercept here. And then I'm going to draw a curve through those points. My parabola is open down, as I expected, because the a value here is negative.